I'm just going to talk briefly about skewness. So here we have some histograms. So remember, the area of the bar represents the frequency, but when we've got equal class widths, it doesn't really differ from a bar chart in terms of shape. Okay, so for this first diagram, you can see that we've got nice symmetrical data. Okay, it's centered on the middle. And so that means in that case, your mean and median and mode are all happening at the same place where the peak is in the center. Okay, right. It's quite widely spread, quite a nice even distribution there. Whereas this one, much more of a peak. We still have very symmetric data, and so that means that the mode, as well, the modal class is the middle. Okay, that's going to match up with the median and the mean. So remember, median, you've got 50% of the data on either side. The mean is where you add them all up and divide by how many there are. If you have a symmetric distribution, the mean is going to be in the middle. And we use X bar to represent a sample mean. So when we've got lots of data, we could list all of the data values, okay, using these little subscripts. So that's the first data point, the second data point, the third data point, the fourth data point, and so on. So we call the mean all of them added up. Okay. This distribution is definitely not symmetric, so let's just see. All right. So if we had started with a nice central heap, symmetrical heap, then what we've kind of done is we've pulled the extreme left end, okay, to the negative direction. So we say that this one is a negative skew. Okay, so a central pile is not being pushed, it's been pulled in the negative direction. Now, in this case, our median is going to be somewhere around here, and we can see that it no longer corresponds with the modal pile necessarily. Okay, but also the mean is always affected by extremes of data. So the median, there will be 50% of the data on either side, and the mean here will be heading in the extremes direction. So the mean is going to be less than the median for a negative skew. Here we have the opposite problem. Okay, so this time the median, we've got about 50% of the area of the bars on either side. I probably won't have got that right, but the median isn't going to be far off this kind of pile on the left. Again, it will differ from the mode, the modal class, but the mean is going to be affected by the extremely positive values. We have got a positive skew. It's like we've got a heap and we've pulled it in the positive direction at one end. Okay, so that the same happens to the mean, which means that the mean is greater than the median this time. Okay, in this situation you can see we've got two modal class, well, two peaks. We've got one modal class but two peaks. The data is fairly symmetric, so actually the mean is going to be approximately, so the median is going to be approximately equal to the mean. Okay, but we call this bimodal data. Even though there's a slight difference in the heights of those modal classes, it's bimodal data because there are two peaks. And then finally, this is pretty even across the board, which means that your mean and your median are going to be somewhere in the central group, but we call this, when it's really evenly spread, a uniform distribution. Okay, it's not skewed, It is sort of symmetric, but really it's not very symmetric. It's a uniform distribution.